A residential foundation is designed to evenly transfer the home's structural loads to the ground. The foundation must provide a solid base for the weight of all other parts of the house. It is critical that the foundation be built following the house plans exactly. Even the slightest variation in the foundation will adversely affect all other aspects of house construction, from floor framing to roof framing. As you will learn, modern construction methods allow for stronger, higher quality foundations than in the past. This video will introduce you to the major steps for constructing different types of modern residential foundations. Anyone planning to work in the construction industry will find the information in this video very useful. The three types of foundations are the slab foundation, crawl space foundation, and the full basement foundation. The slab foundation has a footer without walls and a concrete slab floor. The crawl space foundation has short walls on top of the footer for storage and access under the house. The full basement foundation has tall walls so that the basement can be finished. Residential construction surveying is done to accurately determine the lot boundaries and to locate the building on the lot. The contractor will normally hire a licensed and bonded surveyor to measure and stake out the lot lines and the location of the house foundation. Surveyors commonly use complex computerized surveying instruments to measure angles, distances, and grade accurately. They have specialized skills and commonly use a personal computer and information from local government zoning maps. To stake out the perimeter of the lot, surveyors find established reference points like curbs, the center of a road, or special monuments that mark points on zoning maps. Measurements can then be taken from these reference points to stake off the lot boundaries. If the property is wooded, great care must be used in deciding which trees should be removed. Much depends on where the trees are located and their type. Keep in mind that driving heavy equipment or digging next to trees will damage the root system and may cause them to die in a year or two. Generally, large trees within 10 to 20 feet from the house should be taken down. Mark trees with paint or ribbon so that only the right trees are cut down. Make sure the tree service company is bonded and insured in case someone is injured on the job. Stumps can be ground out using a stump grinding machine, or they can be pulled out with heavy equipment. Building sites on steep slopes or rugged terrain should be rough graded before the building is laid out. Topsoil should be removed and piled where it will not interfere with construction work. This topsoil can be used for the finished grade after the house is built. The plot plan shows the outer perimeter of the house on the lot. Dimensions are given for distances from the outer perimeter of the lot to the corners of the house. The surveyor can then use this drawing to precisely stake out the location of the house foundation. Local zoning ordinances will tell the surveyor and contractor the house setback. House setback is the distance the house must be located from the road and adjoining lots. A typical setback is 20 feet from the road and 5 feet from adjoining property lines. A transit level is commonly used by the surveyor to establish the building corners. Stakes are then driven in the ground and double-checked to mark where on the lot the house will be built. House location stakes are usually driven in the ground a specific distance, typically 5 to 10 feet, from the corners of the house. This distance is normally given on the plot plan. House location stakes are first used during excavation. Excavation involves removing a large quantity of earth for the footer, basement, and slope around the house. The contractor often hires a subcontractor with heavy equipment to complete excavation work. When excavation begins, heavy equipment operators dig the foundation hole next to surveyor stakes. Since the stakes are located several feet from the exact build site, the excavation will be slightly larger than the foundation, so workers have room in the hole for erecting the footings and foundation walls. During excavation, great care must be taken not to disturb virgin earth below the foundation. The heavy equipment is used to carefully scrape off soil as needed without disturbing the soil below the bottom of the footer or basement. Refilling of low spots in the excavation must be avoided because it will be difficult to recompact the fill properly. Foundation settling and cracking could result. The depth of the excavation can be calculated from a study of the vertical section views of the architectural plans. Today, a laser transit level and a laser detector mounted on a graduated level rod are used to quickly and accurately check depth of excavation. To monitor grade and depth of the excavation, set up a laser transit level as an elevation reference point. Set up the level on one side of the lot out of the way of the workers. Level the laser and turn it on. The laser will then spin while emitting a strong laser light beam. You can then use the graduated level rod to determine the height of the soil in relation to the reference point at the laser. This allows the excavator to accurately and quickly remove soil until the site is at the correct elevation. In cold climates, it is important that foundations be located below the frost line. The moisture in the soil above the frost line can freeze and expand. If footings are set too shallow, this will force the foundation upward, causing cracks and serious structural damage. Local building codes usually detail these requirements. Foundations should extend about 8 inches above the finished grade to protect wood members from moisture. A laser system can again be used to check the height of the foundation wall. After the excavation, you must lay out the foundation and build the forms for the foundation footings. If it has rained since foundation excavation, use an electric or engine-driven pump to draw water out of the excavation as needed. You can then lay out the forms for the foundation footing. The footing is a widened concrete base poured onto the ground so that the weight of the house is spread over a large area of soil. The house plans will give the size, shape, and location of the footings. One page of the plan will usually give foundation details and cross-section drawings of the footings. Another page will normally give the top view of the foundation plans. Generally, to lay out the footings, use the back-set house location stakes established by the surveyor. Your plot plan will give the distance the stakes have been placed from the footer. Run nylon layout strings between these stakes for taking measurements to establish the location of the house foundation. Batter boards are sometimes built to ensure the footings are poured in the correct location. The batter board stakes are often made of 2x4s and 1x6s. Since the surveyor stakes are a predetermined distance out from the building line, you can transfer this distance to the top of the batter boards. Nylon layout string and a plumb bob can then be used to locate the building line precisely in the excavation hole. Once all of the perimeter stakes are established that locate the footer, outside form boards can be installed. Your house plans will give a drawing and measurements for laying out the footing. The trend is to use metal stakes and treated plywood forms. The metal stakes drive into the ground more easily. The plywood forms can also be quickly overlapped, eliminating the need to cut the form boards to length. Overlap the boards as needed to construct the footing form according to the measurements given on the house plans. Some contractors still use wood stakes and hand-cut wood forms in geographic areas with soft, sandy soil. The principle of building them is the same, but since the stakes and wood must be cut to length, it is more time-consuming. Use a tape measure to establish the width of the footing. Then, install the adjacent form boards at the correct distance from the outer form. Nail the forms together using duplex or double-headed nails. This will allow you to easily remove the nails and tear down the forms after the pour. After construction, double-check all of the dimensions of the footing. This is critical, since the footer and foundation wall are not easy to tear down and move if installed incorrectly. Some hand digging and leveling of the excavation will probably be necessary as forms are set. Loose dirt and debris must be removed from under the footing. A thicker footing is stronger than one with soft dirt under it. To keep the top of the forms from blowing out or breaking apart during the pour, wrap wire around the stakes and tighten the wire until the forms are square. To prevent the cured concrete from sticking to the forms and to aid in form teardown, spray an approved release agent onto the inside surfaces of the forms. Establish proper elevations at all corner stakes. Then run a chalk line inside the footer forms between these points. Snap the chalk line on the inner surface of the forms. This will give you an elevation guide for pouring the concrete to the correct height. Step footings are needed with a grade change or when called for in the plans. They will require some additional form work. Vertical blocking must be nailed or clamped to the form to contain the concrete until it sets. Column footings are larger pads of concrete that carry more load. They carry weight transmitted to the column from the beams, stringers, and joists of a house. The house plans will give details for making forms for all column footings. Pouring the footing involves filling the form with concrete. The tradesperson making the pour must concentrate on installing the correct amount of concrete to keep the footer level. A laser transit level is commonly used to check the top of the footer pour to make sure it is within accepted tolerances. By lightly placing the level rod on top of the concrete, the laser indicator will audibly and visibly tell you if the top of the footer is too high, too low, or within tolerances. Masonry skills are then used to smooth and level the top of the concrete. A piece of 2x4 is commonly used to cut a key in the top of the footer. The key or groove will help hold the foundation wall in place. The poured footer is often allowed to set up overnight. Footing form boards are removed the next day so they will not stick too tightly to the concrete. Modern drain tile or pipe is usually a perforated, cloth-covered plastic hose that helps protect the foundation from water seepage and possible damage. The drain tile hose is run along the outside of the footer and covered with rock. The drain tile, using gravity or a sump pump, carries water away from the house or to a sewer. Many different types of foundation wall forming systems are available. Their construction principles are similar, however. Run a chalk line on top of the footer to locate one of the foundation walls. The wall location can be found by reading the house plans. Then, as the forms are positioned, the wall forms can be lined up with this chalk line. In the past, wall form panels were made of a special grade of plywood and attached to wood or metal frames. Today, aluminum forms are commonly used to speed the job and to improve quality. They are made of lightweight aluminum with steel locking pins and swing-down clamps. The form sections come in different widths and heights. Special forms are provided for corners and wall ends. For quality work, the forms used must be tight, smooth, defect-free, and properly aligned. Any leakage out of a form tends to weaken the wall by causing honeycombing, a problem that occurs when air pockets form inside the concrete. Wall forms must be strong and well braced to resist the side pressure created by the fluid concrete. Like a huge erector set, the correct size wall form must be used to come up with the needed wall shape, length, and height. As you build the form, place metal ties onto the form pins before installing the next wall section. After you fit one section of form against another, hammer the pins through and the locking levers down to tighten and secure the form. Rebar is thick steel rod. It is commonly run along the top and bottom of poured walls. The rebar is placed on the metal ties. Notches in the ties allow you to wire the rebar in place so it will not move during the pour. With metal forms, pieces of wood attached to C-clamps can be installed where a section of the foundation wall will be shorter or lower than the adjacent wall section. Any gaps between the forms larger than an inch must be sealed by wooden forms. Special framing must also be attached inside the form to create openings for pipes or voids for beams. As with windows and doors, formwork for these structures must be attached to the wall form before the inside form is erected. Fiber, plastic, or metal tubes can be used for small openings. The pour involves filling the wall forms with concrete. As concrete is poured into the form, one worker tamps the pour to remove air pockets and to make sure the bottom of the form is completely full. The concrete is poured to the very top of the form and then troweled level. If the concrete mixer truck cannot reach all the way around to pour the foundation, a concrete pumper truck is often used. The mixer truck pours its load into the back of the pumper truck. Then, the pumper forces the concrete through a long hydraulically actuated boom. A remote control unit is sometimes used so that the operator of the pumper truck can stand next to the nozzle to monitor concrete flow into the foundation wall forms. Antifreeze must be added to the ready-mix concrete if the outside temperature on the day of the pour is below freezing. Local building codes will limit the lowest temperature possible during a pour. Generally, avoid pouring a foundation in temperatures below 20 degrees Fahrenheit. Below this temperature, even additives will not protect the concrete from freezing and structural weakening. If the bottom of the wall form has ice in it, pour salt onto the footer. The salt, or calcium chloride, will melt the ice so the concrete will not be held off the footer by the ice, forming a void at the bottom of the foundation wall. A concrete finisher works behind those pouring to smooth and level the concrete with the top of the wall form. While the concrete is still wet, 1/2-inch anchor bolts are installed into the top of the poured wall. These anchors will be used during floor framing to secure the wood sill. They are spaced not more than 4 feet apart. The anchors should protrude above the poured wall at least 3 inches so that a nut can be installed over the 2x-sill. Wall forms help protect concrete from drying too fast. They should not be removed until the concrete is strong enough to carry the loads that will be placed on it. After the concrete has had enough time to harden, the clamps can be loosened and the forms stripped away. Hammer blows are used to remove the clamps, pins, and metal wedges. A special pry bar is often used to force the forms away from the concrete wall. Any forms for a brick ledge should be broken out and removed. A brick ledge is a small lower step formed along the outside top of the foundation wall for placing the first course of brick or stone veneer. Another wall forming system is ICF, or insulated concrete form construction. After pouring a conventional footer, special forms made of below-grade insulation are stacked and connected together to build the wall forms. Tape, wire, Rebar and special bracing are used to secure these forms. Once poured, the forms stay in place to insulate the outside and inside of the poured wall. Concrete blocks are used for foundation walls and other masonry construction. Concrete block walls are generally not quite as strong as poured concrete, but can reduce construction costs. First, use a chalk line to mark the location of the wall on the footer. Then, lay the first course of blocks without mortar to check the layout. This will avoid unnecessary cutting of the blocks. Next, lay a mortar bed on the footing for the first course of blocks. Corner blocks are laid first. Head joints on the side of the block are buttered before the block is laid. The corners are usually built up first from 4 to 6 courses high. All corner blocks must be at the right height, in line, level, and plumb. The mason will use a level to check this after laying every 3 or 4 blocks. Block foundation walls must also be topped with anchors to secure the sill. Most builders waterproof foundation walls to prevent water or moisture from seeping into the basement. Either an asphalt, synthetic rubber, or plastic-based material is applied to the outside of the wall before backfilling. Asphalt and synthetic waterproofing compounds are often sprayed onto the foundation wall. In northern climates, foundation walls are often insulated to prevent heat loss through the basement wall. Special below-grade insulation board is normally placed onto the foundation wall right after waterproofing. If needed, pieces of wood can be used to hold the insulation board up against the foundation. This wall has been double insulated along the top half where the wall is exposed above the frost line. Less insulation is needed deep below grade. With cavity wall construction, the forms themselves serve to insulate the poured concrete wall. Waterproofing can be done by applying a self-stick rubberized membrane to the outside of the styrofoam outer surface. After the foundation is cured and waterproofing has been completed, the excavation outside the walls must be refilled with earth. This is known as backfilling. Since this places considerable pressure on the wall, the first floor framing and rough flooring are sometimes installed first. Walls should also be braced. This is especially important with concrete block foundations. The finished grade should be sloped away from all sides of the house, so surface water will run away from the foundation. If water puddles along the foundation, it can flow down and clog the drain tile or cause excessive settling, freezing, and cracking.